Hey guys, welcome back. We're going to go ahead and start this week's lesson. The first lesson is going to be over imaginary number system, and then we'll talk about the complex number system. These two things are tightly related, so we will need to do them together. This may be one video or two videos, depending on how long they go. I hope everyone's doing okay and that quarantine is treating you well. Please be safe. Make sure you are following all the recommended procedures and make sure you're washing your hands, guys. So let's go ahead and get started with this lesson. First of all, as a heads up, I am suffering a little bit of allergies, so if I clear my throat, I may not always be able to edit it out or pause it. Just as a heads up, I apologize if if my cough gets annoying. All right, so we have some phrasing here that is important. It says equations such as x squared plus 1 have no real solution. So mathematicians defined imaginary numbers to represent their solutions. So we've always said all real numbers. Well, all real numbers is not imaginary numbers. Now, a lot of people have asked me, Miss, why do we need imaginary numbers? Imaginary numbers are important for lots of reasons. They are important for the development of cell phones and our expanded ability to use them for the internet, for um, I believe lots of other things. I don't remember because it's it's really complicated. But everything that basically, if you're not 100% certain how it works, it probably has to do with imaginary numbers in some way or fashion. We use them a lot, but in everyday life, most of you aren't going to be aware of them. It is, however, important to understand that they exist and they are not difficult to work with. So the imaginary unit is I, and it's defined as the square root of -1. And remember, we normally can't have negative square roots because nothing times itself is negative. -1 times -1 is 1. 1 times 1 is 1. So when the signs are the same, which they would be if you were squaring, the answer would never be negative. But we invented imaginary numbers to deal with that. So a pure imaginary number is written in the form of bi, where b is the real number and I is the imaginary part. Okay, so first thing we're going to practice is simplifying negative square roots. Okay, so we have square root of -9. And so what we're going to do is we're going to break that down. It says rewrite as square root of -1 times a. So we could write that as square root of 9 times -1. And then we can break that down further as the square root of 9 times the square root of -1. Square root of 9 is 3, and the square root of -1 is I. So the square root of -9 is 3i. And I mean, technically, again, plus or minus, but it's not that big a deal right now. Number 2, square root of 196. We have 196 times the square root of -1. And 196, the square root, is 14. Square root of -1 is I. Now, for number 3, we have -5. So that's the square root of 5 times the square root of -1. Square root of 5 is as simple as it can get, and square root of -1 is I. So we're going to put I as the coefficient in front of the radical, I square root 5. Okay? And you'll notice that I'm writing the I slightly different than I normally would. Normally you would see me just write an I with a straight up and down. You can do that, that's fine. It's not special that you have to write it the way I'm doing it now. It's just how I've always seen it since it's almost always italicized when it's printed. So I always write it a little different. All right, so number 4, we are going to break this down as the square root of 80 times the square root of -1. And we're going to break 80 down. So let's factor 80. 80 factors to 1 and 80, 2 and 40, 4 and 20, 5 and 16. We could keep going, but again, here's a perfect square. So we're going to break this down into the square root of 16 times the square root of 5 times the square root of -1. Square root of 16 is 4. Square root of -1 is I. And square root of 5 just stays the same. So it's going to be 4i times the square root of 5. 15, again, we have square root of 32 times the square root of -1. Let's see, 32 is 16 times 2, and it's still going to be the square root of -1. The square root of 16 is 4. Square root of 2 is still just square root of 2. And of course, square root of -1 is I. And then finally, we have the square root of -192. So we're going to need to factor 192 because it's not a perfect square. We know that because 196 is a perfect square, and so is 169. So if we factor, we know it's going to be times square root of -1, square root of 192. All right, 192 is, of course, 1 and 192. And then 2 is going to be 96. 96 isn't a perfect square. Okay, so 3. I know that 192 is divisible by 3 because 1 plus 9 is 10 plus 2 is 12, and 12 is divisible by 3. And we get 64. 64 is a perfect square. So we're going to break this down to the square root of 64 times the square root of 3 times the square root of -1. All right. And so square root of 64 is 8. Square root of -1 is I. Square root of 3 is just square root of 3. All right, so we're going to do a couple more examples just to get the hang of it. So number 7 is solving equations. We are still going to use our backwards order of operations, so our SADMAP. All right, so number 7 is x squared plus 81 equals 0. So the first thing we're going to do is look and see, do we have any addition and subtraction that we can undo? Yes, there's plus 81. So we'll subtract 81 from both sides. And we want x by itself, but it's x squared right now, is equal to -81. And then multiplication and division, no, there's none. Exponent, we're going to undo this exponent. So we're going to take the square root of both sides, and we get x is equal to the square root of -81. Remember, the square root of -81 is the square root of 81 times the square root of -1. Square root of 81 is 9. Square root of -1 is I. So x is equal to 9i. All right, so let's move on to the next one. We have 2x plus 9 equals 1. So again, we're going to go ahead and addition and subtraction first. So we have a plus 9. So subtract 9 from both sides. And we get 2x squared equals -8. And then multiplication division, left to right, we do have some multiplication to undo. So we'll divide both sides by 2. And we'll get x squared equals -4. And then finally an exponent to undo, take the square root. And we get x squared is x equals the square root of -4. So remember, -4 is 4 times -1. Square root of 4 is 2. Square root of -1 is I. Number 9. Again, we're going to go ahead and subtract 15 from both sides because that's our addition and subtraction first. And so we end up with 4x squared minus is equal to negative. Okay, so 4x squared is -24. And then we'll divide both sides by 4. We get x squared equals -6. And then we'll take the square root. And we have square root of 6 times the square root of -1. So you get x equals I, which is the square root of -1, times the square root of 6. And remember, it's square root of 6 because 6 is 2 times 3 and 1 times 6. So chances are it would not simplify. So just make sure you're paying attention. All right. All right, so we're going to go ahead and do number 12 because it has a fraction in it, and we want to verify that we remember what our fractions are. So first, we are still going to be following our SADMAP. Remember, it's always a good idea to jot down which order of operations you're doing. If you are not solving, so you're just evaluating. There are no x's. You use PEMDAS. If you are solving to find out what a missing value is, you are undoing, so you go backwards. All right, so number 12, we are going to do our addition and subtraction. There's a -1, so we're going to add 1 to both sides. And that gives me -2 over 3 x squared is equal to 18. And now we need to get rid of a fraction. Now to get rid of a fraction, you multiply by its reciprocal. So we are going to multiply both sides by -3 over 2. Okay? And so that leaves me with just x squared on the left-hand side. All right, so 18 times -3 over 2. I'm going to cross simplify. 18 and 2 is 9. 9 times -3 is -27. And then we're going to take the square root. So x equals square root of 27 times square root of -1. 27 is 9 and 3. So it is the square root of 9 times the square root of 3. And so we have 3, which is the square root of 9, I, which is the square root of -1, times the square root of 3, because that's the square root of 3. All right, so remembering the powers of I to make our lives a little easier so we can know what they are, it's going to be pretty simple. So I is to the first, anything to the first power is just itself, so it's just I squared is I times I. Now remember that's the square root of -1 times the square root of -1. And remember, anytime you have square root times the square root, it gets rid of itself like that. So I times I is -1. All right, I to the third, I times I times I. Well, we have -1, I. I times I times I times I. For I to the fourth is 1, because I times I is -1, I times I is -1. -1 times -1 is 1. I to the fifth, I times I times I times I times I. Every two i's is a -1, so this is just I. And then we have I to the sixth, 1, 2, 3, 4, 5, and 6. And that's going to be -1. And then we have I, 2, 3, 4, 5, 6, 7. And I times I is -1 times I times I is -1. So it's -1 times -1 times -1 is -1 I. And we're going to leave out that 1. So -I. And then I to the fourth, 2, or I to the eighth, see, 4, 5, 6, 7, and 8 is just 1. So the powers of I can be either I, -1, -I, or 1. And it's based on the pattern. Okay? So I to the 15th, 15 is a power of 5. So that would be like I to the 5th times I to the 5th times I to the 5th. All right, so that's I to the 5th is I times I, which is -1. I to the 5th is I, so it's -I. Okay, so we're going to divide it by one of these numbers. It is divisible by 2. 62 is divisible by 2. Let's see. Is it divisible by 4? No, and not by 3. So it's going to be I to the 62 is divisible by 2. So that's going to be -1. All right, so we're going to do some examples of products of pure imaginary numbers. Products, again, means we're going to multiply. All right, so first off, number 15, we have 4i times 7i. So that's the same thing as 4 times 7 and I times I. 4 times 7 is 28. I times I is -1. So the answer is 20. All right, so we have three i's in here. I to the third, as we saw earlier, was negative I. And we have 4 times 2, with negative 4 times 2, which is negative 8, times 9 is negative 72, or positive 72, because 72. Negative 8 times negative 9. All right, and so 72 times negative I is negative 72I. All right, 17, 2I to the third. That's 2 to the third times I to the third times 5I. Now we have 4 i's total here because we have 3 here and 1 here. So we know there's going to be times 1 because it's I to the fourth. And we have 2 to the third. That's going to be 8 times 5. 8 times 5 is 40. I is by itself. All right, number 18, I square root of 3 squared plus negative 8I squared. This is going to be a little bit tedious, but it's perfectly fine. So we're going to break it down. We have I squared, square root of 3 squared, negative 8 squared, and again, I squared. All right, I squared and I squared. That means I have 4 i's. So there's me a times 1 in here. So that's done with that. I forgot my square there. Negative 3 times the square root of 3 times the square root of 3 is 3. And negative 8 squared is 64. And then we need to multiply 64 times 3 times 1, but we all know that anything times 1 is itself. So 64 times 3 is 192. All right, number 19. First, we're going to take I out of both of these so that we're going to have I square root of 18 times I square root of 10. And then we multiply these together, so we have I times I. And then we have square root of 18 times the square root of 10. And so I times I is negative 1. Square root of 18 times square root of 10 is square root of 180. And so we're going to go ahead and factor that. So 180, so we can simplify, is 1 and 180, 2 and 90, 3 and 64. Let's see, 180 divided by 4. 4 times 4 times 4. So it's going to be 45. Let's see. Divide it by 5. All right, goes into 18 3 times. 3 times 5 is 15. 18 minus 15 is 3. Bring down the 0. 5 goes into 36 times, so it's 5 and 36. 36 is our perfect square. So that's going to be 36 times 5. Square root of 36 is 6. Root 5 is root 5 times negative 1. So we have negative 6 square root of 5. And then finally, we have negative 24 times negative 3, or square root of negative 24 times square root of negative 3 times the square root of negative 2. Again, let's take out the I first. So we have I square root of 24, I square root of 3, I square root of 2. All right, so what we're going to do is we can multiply these numbers together, but we can also break them down to make them smaller. So I times I times I, that's negative I. Okay, so we took care of all the i's. And I can break this into 4 and 6. So that's going to be 2 square root 6 times square root of 3 times square root of 2. 3 times 2 is 6. So that's the square root of 6. Square root of 6 times the square root of 6 is 6. So we're going to end up with negative I times 2 times 6. And that's going to be negative 12. All right, so I'm going to wrap that up right here so that the lesson is relatively short and you can keep the video with the correct assignment. Please make sure that you are submitting the Google Forms as they need to be done. And what I will do for this week is basically put what is the answer to this one in a Google doc, so that make it easier for you. Um, I will submit that to you and you will make a copy. So remember, this is how you do that. All right, so remember if you want to edit a document that I send on Google Classroom through Google Docs, remember you're going to have to go to File, Make a Copy, Copy of. Instead of copy of, please go ahead and put your name there. All right. And then you'll just click OK. Do not share it with the same people. Do not copy comments and suggestions. So that way you can have your own copy of the answer document. And I will do this for both this one and for the complex number lesson that we're about to start. So that's all I have for you right now. Make sure you get that homework done as quickly as possible. And I will talk to you later. Bye.